Well, here we go, guys. We're going to blast off into the world of the trigonometric ratios. So, 5, 4, 3, 2, 1, blast off. And we're going to talk about similar right-angled triangles. Now, first of all, that's to get the flavour of what these trigonometric ratios are all about. So, in two similar right-angled triangles, which we'll see in a minute, the angles are the same and the corresponding sides are in the same ratio. That is, if they're similar. That means that they're scale models of each other. Here they come. Right now, these are the same shape, e.g. they are similar. One is a scale model of the other. So what I'm actually saying there, that this angle here therefore will be the same as that angle there, and that this angle here will be the same as this angle here. And you'll notice also that the corresponding sides are in the same ratio. In other words, this side here is exactly double that side in this case. That side there is double this side, and this one, yes, you guessed it, is double this one, right? These are exactly the same shape. This one's just a smaller version of this one. So the triangles are called similar, and they're right angle triangles. Now, this sets the scene for what we're doing with trigonometry. So therefore the corresponding sides are in the same ratio as we have discovered. AB over DE. Now what's that? AB, yes, over DE would be a half. Yes, wouldn't it? And AC, let's get that right. AC over DF is a half, and BC, this beastie, over EF would also be a half. They're all equal to a half. Yes, you agree? Now, to write this using the side lengths of the triangles gives yes. Well, we did all that. It's equal to a half. Yes, it's equal to a half. I showed you that. Yes, you agree? Okay, let's move on. Now, this is very exciting. This means, guys and gals, that for right-angled triangles, when the angles are fixed, the ratios of the sides in the triangles are constant because of this similarity property, okay? So this means we can examine this idea further by completing the following activity. Now, I don't want you to actually do this, but I'll just show you. Using a protractor and ruler, you could draw a 70-degree angle, for example 70 degrees, and you could measure a horizontal distance of 3 centimetres, 7 centimetres, 10, and 10 centimetres as demonstrated below. Now, this is the thing. You see, look, in this triangle here, yeah, with this angle here, this triangle EFG is exactly the same shape as triangle GDC, and is exactly the same shape as triangle GBA. They're all the same shape. They all, therefore, have the same 70-degree angle in them because they're right-angle triangles, and they are the same shape. And because they are right-angle triangles, we can do trigonometry in them. So what we can say, yes, they're all scale models of each other, and therefore we can say that the ratios of the corresponding sides in each triangle are the same. This is the basis of trigonometry. E.g., right, now look, watch this, EF over EG. Now that means EF over EG, that's this opposite angle, opposite the 70 degrees, and the hypotenuse, so opposite over hypotenuse of the small triangle, will be the same result as this opposite over this hypotenuse in this triangle, which will also be the same result as this opposite over this hypotenuse in this triangle, because the ratios of those sides, because the fact that they are in the same proportion to each other, because the shapes are identical, the ratios of those sides will be the same in each case, and that equals sine 70. We also know that FG, okay, that's this called the adjacent side, okay, the side next to the angle. FG over EG equals DG over CG equals BG over AG, and that's also equal to cos 70. That's cosine 70. And lastly, we know that EF, this is tan now, EF over FG equals CD over DG equals AB over BG equals tangent 70. Isn't that mighty fine? It's incredible. The fact that these are right angles means we can do trigonometry on them, okay? You don't have to have right angles to have similar triangles, but you do have to have right angle triangles to be able to do trigonometry. That's the thing I wanted to clarify. Alright, now, we've got to calculate the value of each of the following correct to 4 decimal places using a calculator. Now, this one and this one. Now, what I'm going to do is I'm going to demonstrate this for you on the TI CAS handheld device, because that's the one we use in our school. If you haven't got a TI CAS handheld device, I apologise to you, but you may still want to keep watching, or you may want to switch me off and get rid of me. But here we go. Here it comes. This is how we set up. First of all, we've got to set up the CAS handheld device. Now, what you do is you press the on button to reveal the home screen. This screen here is the home screen, alright? And then what you do is you select new document here using the navigation bar. Okay, that's this navigation bar here. You can scroll across if you're not already in this right hand column, and then select by scrolling up or down to get new document, and then you hit enter. Then you hit enter. Okay, there is the navigation bar for you. Aha. And then we hit enter. Now what you'll get then is you'll get this screen here where you get all these options. So you scroll using the navigation bar to get add calculator, and then you press enter, and there's enter. Yes, there you go. Now the next thing you do, that gets you a calculator screen. Now we've got to put this calculator in degree mode, so as opposed to radian mode. So what you do is you press the on key again, which is up here, to display the home screen, which is here. This time you scroll down to settings. Okay, select settings and then hit enter, and you will get this. Oh, there's the enter. Hello, Mr. Enter. There he is. Now, what happens then is you're going to get this sub menu, and we scroll down till we get document settings using the navigation bar there, and then you hit enter. Okay, and then you're going to get this screen. Now, using the navigation bar, I want that's that bar. You're getting used to the navigation bar by now. You move down to the menu to the angle here. This thing down here by scrolling down with your navigation bar. Then you go, I move the navigation bar to the right, this one here. I press that one, and then it reveals a sub menu. Yeah, that's angle. Then you basically use the navigation bar, push it to the right, and you'll get that sub menu. Okay, and then scroll down using the navigation bar to degrees, and then hit enter. Then hit enter there, and then you press enter again to leave that settings screen, having now set your calculator to degree mode. Now, that was a lot of mucking around, wasn't it? But never mind, we've got the thing now set up with a calculator screen, and we're in degree mode. Now, when you leave the calculator, when you leave the settings screen, you'll be back to the home screen. So I want you to select the current, means the current document, and hit enter. Okay, there it is, and that'll take you back to the calculator screen. Alright, now, what I want you to do now is select trig, which is over here, right, on your calculator. There it is. And then you'll get that screen there. Okay, so I want you to use the navigation bar to move over to COS, right? There one, yeah, move that to scroll over to COS and then hit enter, right? Good show now. You've got COS on the screen now, and I want you to then enter 65 from your keypad here. 65 to help us thrive and keep us alive. And then you need a degree symbol after that. Okay, so what you then do is you select control and then catalogue. Now I'll show you where they are. There's control, and the catalogue is a book thingy there. Okay, control catalogue, and you will get this funny looking thing here, and then you scroll till you get to this degree symbol. Yes, and then you hit enter. Okay, and then you'll get this. Right, you'll get 65 degrees. Isn't that great? Now you've got to enter 57 minutes. So we've got to enter 57. And then you go control catalogue again. You see I've entered the 57. Now you go control catalogue and you look for the minutes symbol, which is just down from the degree symbol here. So you would scroll maybe down and then along here till you got to there. And then yes, yes, and yes. And then hit enter. Right? And then when you do that, you've done your cos 65 degrees 57 minutes, right? Yes, you have indeed. Now what you've got to do now is you've got to get the answer to that by hitting control enter. So there's control, there's enter, and that means you'll get a decimal value instead of what's known as an exact value for that thingy. And there she be. There's the answer, guys, to no less than 6 decimal places in that case. You can actually regulate the number of decimal places you want. But we really only want these to 4, but that's outdone itself, hasn't it? The answer is on the screen. So we've just done cos of 65 degrees and 57 minutes in style, haven't we? There it is. Now we're going to do tan 56 degrees 45 minutes and no less than 30 seconds. Okay, that's no problem to us. The steps for tan 56 degrees and 45 minutes and 30 seconds are exactly the same in procedure as we just did for cos 65 degrees and 57 minutes, except, guys and gals, that the seconds symbol, this little funny looking double dash here, is made up of 2 consecutive minute symbols. Well, wouldn't you know? Wouldn't you know? So there it is. Look, 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 look. See, I did that. I went to control book twice to get those 2 consecutive little ticky things, yeah? And I got this. Look at that. So apparently tan of 56 degrees, 45 minutes and 30 seconds is 1.52574. It's marvellous, isn't it? Aren't these, they're computers, these calculators. They're amazing things. They have more computing power than what they were able to use sending the first man to the moon, by the way. Isn't that staggering? So calculate the size of angle theta, that's a little Greek theta, T-H-E-T-A, correct to the nearest degree, given that sine of theta is this. Well, this is like a backwards step. We know that sine theta is 0.6583. We've got to work out what theta is. So we use this symbol. This means inverse sine, or the angle whose sine is. That's the English grammatical interpretation of that symbology. The angle whose sine is this on the CAS handheld. So here we go. Now you press trig again, which is this beastie over here, right? Let's just do that. That's trig, and then you get that, all that stuff. Now you want to go down, scroll down using your navigation bar to inverse sine. Okay, and then hit enter. Hit enter, and what you'll get is that, and then you enter 0.6583 on your keypad, and then hit enter, and you'll get this marvellous result, okay? But we have to answer this question to the nearest degree. So you tell me, what is the answer to the nearest whole number of degrees, guys? That's enter. Hello, enter. It is what? It is. It's 41 degrees, okay, to the nearest degree. Yes? All right. We're going well, aren't we? Now, what's this other one we've got to do? To the nearest... Oh, this is something different. We've got to do to the nearest minute. Look. Given that cos theta is that, and to the nearest second, my goodness, given that tan theta equals that. Well, look, I'm going to show you something else now, something wonderful to enable you to do this, okay? To do this. It's a little bit more of CAS skullduggery. So we need the angle in part A, whose cos is 0.2547. So let's just do that. And when we have the answer on the CAS handheld, we convert it into what's known as degrees, minutes and seconds format, which I'll show you how to do. And then we round to the nearest minute. Now, in order to do that, guys, you've got to know something. There are 60 seconds in a minute. I know, you're saying, well, duh, we know there's 60 seconds in a minute, but you're thinking about time on the clock. This is degrees, minutes and seconds, right? So 1/60th of a degree is a minute, and 1/60th of a minute is a second in angular terminology. Okay, in case you didn't know that, I just needed to explain that to you. Okay. Now, hence, if there are 30 or more seconds, to round off to the nearest minute, we'd bump up the number of minutes up one. Yes. If there were less than 30 seconds, we'd round down with our minutes, yeah, to get to the nearest minute. Here are the CAS steps. I know, it's very gripping. Right, now, enter. Now, you know how to do this by now. You're going to enter inverse cos, using the trig menu and all the rest of it, of 0.2587, and then hit Control Enter, and you'll get this, right? Now, that's the answer, 75.2442 degrees. But, you know, we've got to answer this to the nearest minute, right? So we've got to dissect all this 0.244 degrees down into, you know, how many minutes and how many seconds is that, all right? So, how do we do that? Yes, that's Control, that's Enter, and that's what you get, yeah? So that's great. The answer is 75.2442. Now, what you've got to do now to get this into degrees and minutes format, guys and gals, is select Catalogue. Now, the catalogue is just the book, this beastie here. So you select that, and what you get is all this stuff. So what we're going to do is, first of all, we have to type 1. Type 1 on your keypad, this is this little beastie here, to get tab 1 showing on your catalogue, right? Now we've got the right tab, okay? There's different things under every tab. Type 1, you'll get that tab. Then type D on your keypad, where's that? There it is, there. To get to the top of the D list of options, which are in here. Now that's the first item of the Ds. They're all alphabetically placed in that, under that tab 1. Now what you do now is you scroll down till you find DMS using your navigator, trusty navigator thingy, and then when you get that, you hit enter. You hit enter, and what do you get? Look, you get this. So it says, oh, okay, he wants to convert answer to degrees, minutes and seconds format, and then what happens then? Wow, look, it converts it into 75 degrees, 14 minutes and 39.0859 seconds. Now that's what I call an accurate angle. Accurateville, USA, isn't it? Incredible. So now what do we got to do before we get too carried away is do it to the nearest minute, don't we? Well, you can look, 39 seconds. So which way do we round, guys? Which way do we round? Yes, that's the answer. I know it's the answer, but it's not the answer as we have to quote it. We have to say it's 75 degrees and round this little beastie up here because that's more than 30. 30 or more, we round up that to 15 minutes. That's your answer. Okay, this one here, to the nearest second now. Good heavens above, to the nearest second. So, all right, we know what to do. CAS steps are shown. Here we go. So we're going to get here. So you go tan, inverse tan, you know what to do using the trig thingy. Inverse tan of that, you get this thing after I've converted it to DMS. So the whole thing's done here for you. So inverse tan of this gets you this. Go to the book, go to tab 1, scroll down to DMS, hit enter, you'll get this. Right, now to the nearest second, 67 degrees, 4 minutes, 15.8 seconds. So come on, to the nearest second, that's going to be what? It's going to be, of course it is, the answer's down here, just awaiting you to feast your eyes upon, 16 seconds. So it's 67 degrees, 4 minutes, 16 seconds, yeah? Excellento. Now, that's the calculator expose for you. That's finished now. We're going to do some real-life trig now. This is the sine ratio. It's defined as the ratio of the length of the side opposite, theta, to the length of the hypotenuse. Sine theta is opposite over hypotenuse. Here's theta. To get to the opposite, you always kick the football out from the goal, which is where the angle is, and you will hit the opposite. In the small triangle, it's this one. In the medium triangle, it's this one. In the big triangle, it's that one. And you'll get the same ratio for sine of theta in every one of those triangles, because remember, they're all scale models of each other, they're all the same shape, and because they're right angle triangles, we can do trigonometry on them. Okay, get that? Yeah, the sine of the angle is not dependent on the size of the right angle triangle, as I've been explaining to you, as all these triangles are similar in shape. Okay, and here comes cos. Cos is the adjacent over the hypotenuse, okay? The adjacent is the one next door to the angle, which is not the hypotenuse, and the hypotenuse is easy to pick because it's opposite the right angle. So cos is A over h, and again, cos does not depend on the size of the right angle triangle. Of course it does not, because they're all similar, they're all the same shape, and it's all a matter of ratios. Now, the tangent, that's the last one. Tan is opposite over adjacent. Opposite over adjacent, where O is the length of the side opposite. Yes, that's it. Opposite. And adjacent is the one next to the angle, but not the hypotenuse. So, yes. So, tan is O over A, opposite over adjacent, right? Again, the tangent ratio does not depend on the size of the right angle triangle. It's amazing. So you get the acronym, which we're also used to. SO, CAR, TOA. Okay? Sine is opposite over hypotenuse. Cos is adjacent over hypotenuse. And tan is opposite over adjacent. My goodness. Feast your eyes upon it, guys. 'Tis truly beautiful. Now, we're nearly finished now. We've just got a couple of examples to do just to round this off. For the triangle shown, write the expressions for the sine, the cosine, and the tangent ratios of the given angle. Well, we can do that. First of all, we've got to work out which one's opposite, which one's adjacent, and which one's hypotenuse. Well, we know which one's the hypotenuse. You just kick the goal out from the right angle. Boom! Hello, Mr. Hypotenuse. And to get the opposite, we kick the goal out from the angle straight out from goal. Bang! Hello, Mr. Opposite. Therefore, the other one must be the adjacent, right? So, sine equals A over C because that's opposite over hypotenuse. Cos equals B over C because that's the adjacent over the hypotenuse. And you guessed it, tan is, what is it? Yes, it's A over B because that is the opposite over the adjacent. So, CAR, TOA. Mr. Box, thank you, Mr. Box, and hello to you. Now, what are we doing now, guys? I think this is the last thing we have to do. Write the trigonometric ratio which must be used in order to find the value of the pronumeral in each of the following triangles and set up a suitable equation. Well, I don't think that's any problem at all. Let's take A today, hooray. What can we say? Well, what we can say is that kick the football out from the goal. Hello, Mr. Opposite. And this guy is the one opposite the right angle. He's the hypotenuse. So there you go. Kick the goal, found the opposite. And this guy's the hypotenuse. So now we're right, aren't we? Do we have to do... okay, so now we have to work out which ratio must be used and then set up a suitable equation. All right, look. We've got the opposite. We've got the hypotenuse. We're not going to worry about this side here because there's nothing doing down here. This one is 6, this one's 15. We know this is B, so this is the angle we have to involve. So I'd say we would be using which one? Sine, isn't it? Yes, it's got to be sine. Yep, of course it does. So therefore, sine of B equals, what does it equal? Yes, it equals 6 over 15. Happy? And put a box around that. Actually, that equals 2 over 5. My goodness. That'll keep us alive, won't it? Yes, because 3 goes into that 2 times, 3 goes into that 5 times. It's 2 over 5 in its simplest form, which is the way we should quote it. Yes? Very good. Now, let's do B and see what we can see in B for free. So this is 50 degrees. Now, come on, which sides are which? Kick the football. Boom! Mr. Opposite. And we have to involve him because we have to use the X in the equation, don't we? And this little beastie here is going to be the adjacent, because this one's the hypotenuse, yeah? So that's the opposite, kick the football, and there's the opposite. This guy here is the adjacent, isn't he? So, come on, which ratio do we use? Well, you know, don't you? It's TOA. Yes, opposite over adjacent. So, okay, tan of 50 equals X over 18, doesn't it? And if we wanted to rearrange that, I think that's good enough as it is, but if we wanted to rearrange it so that we can make X the subject, we would say that X would be 18 tan of 50 degrees, and of course you can look that up on the calculator without any trouble at all. And if you wanted to work out this one, by the way, guys, you would just go inverse sine, the angle whose sine is 2 over 5, and you'd get your answer, yeah? And everything would be mighty fine. Yes, in fact, divine. So here's your summary, and My goodness, what a great summary this is. So we'll just better whip through it pretty quickly. When you're using your calculator to find the values of sine, cosine and tangent, make sure the calculator is in degree mode. Now you remember we did that at the beginning? We did, didn't we? Yes? To find the size of an angle whose sine, cosine or tangent is given, yes, to find the size of an angle whose sine, cosine or tangent is given, perform an inverse operation, that is inverse sine, inverse cos or inverse tan. Yes, and you saw me do that on the calculator, didn't you? Yes, use the calculator's conversion function to convert between decimal degrees and degrees, minutes and seconds. I used that DMS function, didn't I, from the book? Yes. There are 60 minutes in a degree and 60 seconds in a minute. Yes. Shock horror, now you know that. And the three trig ratios you know are SO, CA, TOA, don't you? Okay, what's next? The three ratios are abbreviated to SO, CA, TOA, of course they are. And to determine which trig ratio to use, follow these steps, guys. First of all, label the sides of the right angle triangle that are either given or need to be found using the symbols O, A or H, that is opposite, adjacent or hypotenuse, with respect to the angle in question, because it really does depend on the angle you're using as to which one's opposite, which one's adjacent and which one's the hypotenuse is always the same, but the opposite and the adjacents depend on the angle you're using, right? That's pretty important. Right, consider the sides that are involved and write the trig ratio to involve them, containing both of those sides, yes, with that angle as well that you've got to involve. Okay, and use SO, CA, TOA to assist you. This is a great summary, isn't it? Then identify the values of the pronumerals in the ratio, the ones that you have to find, and substitute the given values in the ratio. And Bob is your uncle. Indeed he is, and you're a star. Right, well, you'll go far, but please go and do some practice, and please get good at using your calculator. If you haven't got a TI handheld, you'll have to figure out from someone who can show you how to get good at using your calculator. But your calculator really, as you get up into senior years of secondary school, it has to become like an extension of your arm and your brain. You have to get so good at using it. Particularly if you're using a CAS syllabus, which stands for Computer Algebra Systems, and those wonderful little handheld devices can do symbolic algebra. They can just about do everything but make a cup of tea for you. So, speaking of which, I think I'll go off and make one now. And thank you for coming to see me. I hope you got something out of it, and I'll see you next time. Bye bye.